Okay, hello everyone. Today we're going to look at the probability of multiple events. In other words, a couple things happening. All right? What's the probability of a couple things happening? Today's essential question, how does the relationship between two events affect their probability of occurring? All right? Events affect each other sometimes. The three types of multiple events we're going to look at dependent events, independent events, and mutually exclusive events. When the outcome of one event affects the outcome of a second, the two events are called dependent events. Okay, as an example, the probability of choosing a blue ball the second time, it is affected by the first selection here. All right? The first selection, if I pick a red ball, well, the second probability of picking a blue ball is 2 out of 4. But here, if I choose a blue ball the first time, then the second time the probability of picking a blue ball is only 1 out of 4. All right, those are dependent events because the probability of the second selection is affected by the first selection. Oops. When the outcome of one event does not affect the outcome of a second event, the two events are called independent. As an example, if I roll a dice and then spin the spinner, all right, the outcome of the dice roll does not affect the outcome of the spinner. Now, if A and B are independent events, all right, one does not affect the other, then the probability that A and B, that they both happen, is each individual probability multiplied together. In other words, the probability that they both happen is less than the probability that either one happens individually. So if I wanted to know the probability of rolling a 3 and getting blue when I spin the spinner, rolling a 3 individually is 1 out of 6. And getting blue on the spinner is 1 out of 4 because there are 4 spots here and they all have the same area. So the probability of rolling a 3 and spinning blue on the spinner is 1 out of 24. You multiply 1/6 times 1/4. It's around 4.2%. When two events cannot happen at the same time, the events are called mutually exclusive. All right? When events are mutually exclusive, the probability that either one of them happens, not both happening because they cannot both happen at the same time, the probability that they both happen is 0. I'm talking about the probability that either one happens is the probability of A happening plus the probability of B happening. You add them together. In other words, the probability that either one happens is greater than the probability that either one of them happen individually. As an example, I cannot roll a 2 and a 3 on the same roll of the dice. I can't do that. Those are mutually exclusive events. So the probability of getting a 2 or a 3, you would add them together. 1/6 plus 1/6, I get 1/3. 2/6 is 1/3. So the probability, of course, of getting a 2 or a 3 is 33%. Now, if this is where it gets a little complicated. If A and B are not mutually exclusive events, in other words, they could happen at the same time, then the probability that either one of them happens, A or B, is the probability that A happens plus the probability that B happens. But then you have to subtract out the probability that they both happen. All right, because you've actually added that in twice when you do the probability of A plus the probability of B. You have to subtract out the part they have in common. All right, as an example, what's the probability of rolling an even number and a number less than 3? Or a number less than 3, I should say. There's a probability of rolling an even number is 1/6, half, right? I can roll a 2, a 4, or a 6. Right, the probability of rolling a number less than 3 is 2/6. I can roll a 1 or a 2. Now the probability that they both happen at once, that I roll an even number and a number less than 3, there is one way to do that. It's rolling the number 2. The number 2 is even, and it's less than 3. So of course, when I multiply 1/2 times 0.33, I get around 17%. So the probability of rolling either an even number or a number less than 3 is 1/2 plus 1/3, and then you subtract the 1/6. All right, you end up with 66%. And guys, we'll go through that. It's the first time you've seen it. It's a little complicated. It's okay. All right, you're going to classify some scenarios as dependent or independent. As an example, if I select a month of the year at random, and I select some number between 1 and 20, are those dependent or independent? Does one affect the other? No, guys, those are independent events. All right, selecting a month and a number, the selection of the month doesn't affect the number at all, not 1 through 20. All right? Because if I was going to select a letter of the alphabet at random, and then select one of the remaining letters at random, is that dependent or independent? All right, guys, those are dependent events. All right, because the second selection will be affected by the first selection because I'm not replacing it. I'm selecting from some of the remaining letters. All right. All right, another example. If Q and R are independent events, then find the probability that Q and R happen. Remember, you just multiply them together. Probability of Q is 1/4. The probability of R is 2/3. You multiply them together. The probability that they both happen is less than the probability that either one happens individually. All right, are these mutually exclusive events? Using a standard deck of playing cards, can I select a diamond and a club at the same time? Well, these are mutually exclusive because you cannot select a diamond and a club at the same time. All right, what about can I select a heart and a queen at the same time? All right, these are not mutually exclusive because I could select the queen of hearts. They both could happen at the same time. So it's not mutually exclusive. Okay? Now, if S and T are mutually exclusive, again, find the probability that S or T happens. Just add them together. 5/8 plus 1/8. All right, is 6/8, 3/4, 75%. Just add them together. Okay? All right, so the last example is probably the hardest one. S and T are not mutually exclusive events. A bowl of fruit. What's the probability of choosing a green or an apple? All right. Well, there's the probability of choosing something green. There's 3 of them. There's 2 green apples and 1 green lime. The probability of choosing an apple, well, there's 5 apples. There's 2 green ones and 3 red ones. All right, but I have to subtract out the green apples. There's 2 of them. Because I added the 2 green apples here in the 3/10. They're in there. And I added the 2 green apples in the 5/10. That's in there too. So I got to subtract one of those out. All right, they're probably that they both happen at the same time. I end up with 6/10 or 60%. And guys, I'm over time, so I have to stop here. Today's vocabulary words are listed right there. And that's it. Thanks, y'all.